Alright, the last concept that's new in section 1 is the exterior angle's relationship to the interior angles. It's not always clear what an exterior angle is. The interior angle is kind of straightforward. Oh, it's on the inside? Oh, yeah, it should be called an interior angle. But here's the thing with exterior. We extend the side. So there's these light blue lines here that have been extended, and they're what create the exterior angles. This angle here is an exterior angle. This angle here is an exterior angle. This angle here is an exterior angle. Just be clear, the exterior angle is over here. So an exterior angle is formed by extending the side of a triangle. Now that we know what it looks like, if I would just take a quick look, this angle here, this one that I drew in red, this angle here, this one in red, is supplementary because it's a linear pair with this interior angle. So that means this angle plus this one here have to add up to be 180. Oh, wait a second. If these two angles have to add up to be 180, and these three angles add up to be 180, well, doesn't that mean, I know supplementary is only two angles, but these two angles both have to sum up. These two angles both have to sum up to be 180, and these two and this one have to be sum up to 180. So I essentially have two pairs of angles, or two things supplementary to the same angle. So therefore, they have to be, the word would be equal measure. Congruent would make sense here because I have two angles being congruent to one. But two angles having the same measure as one angle. And that's what the exterior angle theorem says. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So over here, I have angle 1 being this outside angle right here. Right here. It's going to equal the addition of measure of angle A plus measure of angle C equals measure of angle 1. One thing that we need to make sure that we don't do is call this angle here the vertical angle to the interior angle. It doesn't actually have a name. It's on the outside, but we don't call it anything. Not in this class, at least. Alright, so let's try and apply it. Find the value of the numbered angles. If I look here, I see a really complicated figure. Where do I even start? Well, there's three possible spots. First of all, I could start here. That triangle that I see there now, I have only one of the three measures. Probably not a good place to start. The next idea is, why not here? Alright, let's just look at the last one, here. Alright, of the three, I thought this one here was the easiest. The reason for that is, I can find angle 5 here. If I look real carefully, this is basically what I got here. This upper right corner, in this case, where the 10 and the 50 is, combined equals 60. I have a right angle, and I'm looking for this angle over here. If this is 60, this is a right angle, that means this angle over here has to be, well, let's do the triangle sum theorem. X plus 60 plus 90 equals 180. Solve for x. X plus 150 equals 180. Last but not least, x equals 30. Alright, in this case, my x, though, was measure of angle 5. So I'm going to write off in the upper right-hand corner here, measure of angle 5 equals 30 degrees. Alright, so I found one of the angles that I could use. Sweet. At this point, I'm going to erase this. Because this triangle, I found every single piece of information that I could possibly hope to find with it. So my next goal is to see where else I could use this information. So I go back just a little bit. Oh wait, I know that that angle over there is 10. I know angle 5 is 30. So if I add 30 plus 10 plus measure of angle 4, that should be 180. So 30 plus 10 plus measure of angle 4 equals 180. Solve for measure of angle 4, and you should not be surprised to get 140. So I've now got 2 of the 6 done. So measure of angle 4 is 140. The next triangle that I want to look at is actually going to be this one. In particular, what I'll be looking at is angle 3 here. Why? Because it's the exterior angle of this first triangle that we were looking at. And because it's the exterior angle, that means angle 3 is the sum of angle 5 and 10 degrees. If I look, angle 5 is 30, 10 is 10, 30 plus 10 I'm pretty sure is 40. So measure of angle 3 is 40. Let's double check. Angle 3 and angle 4 is a linear pair, which means it's supplementary. Which means angle 4 and angle 3 have to add up to be, at least their measures do, to be 140. Sorry, to be 180. Measure of angle 4 is 140, measure of angle 3 is 40. 140 plus 40 is 180. Good. So now if I would just look at this triangle over here, this one right here, angle 6, angle 3, and the right angle, well, I know angle 3 is 40. I know the right angle is a right angle. So 40 plus 90 plus measure of angle 6 equals 180. Solve for measure of angle 6. And you should get, if done correctly, 60 degrees. Hold on. If done correctly, you should get measure of angle 6 to be 50 degrees. See, we all make mistakes. Whoops, my bad. Moving on. Oops, nope. So I still have angle 1 and angle 2 to take care of. If I look at my diagram, I could continue to go with these different types of triangles. Go ahead and try and find out what they are. Usually exterior angles and different things of a triangle. However, I'm going to take a little bit of a shortcut. Angle 3 and angle 2 here are vertical angles. Same thing with angle 1 and angle 4. So that means measure of angle 2 is the same as measure of angle 3, which is 40 degrees for measure of angle 2. And measure of angle 1 is the same as measure of angle 4, so 140 degrees. This here is my answer. There we go, example 3. If you did this correctly, this is what you should have got. There we go. Again, that's measure of angle 3, 5 being, measure of angle 1 being 140 degrees. Measure of angle 2 being 40 degrees. Measure of angle 3 being 40 degrees. Measure of angle 4 being 140 degrees. Measure of angle 5 being 30 degrees. And measure of angle 6 being 50 degrees. Alright, we have one last example. Find the value of x. If I look, x plus 80 is the exterior angle. I'm given 2 interior angles. Go ahead, see what you would do here. If this is what you said, good job. The exterior angle is equal to the sum of the 2 non-adjacent interior angles. So in this case, 40 and 3x are the 2 non-adjacent interior angles. X plus 80 is the exterior angle. So these two quantities have to equal. Now it's just a matter of solve for x. So on this time, I'm going to move all the x's to one side. So I get 40 plus 2x, because I subtracted x from both sides, equals 80. Then I'm going to subtract 40 from both sides, and I get 2x to be 40. And last but not least, I divide both sides by 2, and I get x to be 20. These are similar types of examples, but you have to make sure that you get the 3 concepts. Knowing how to classify a triangle, knowing what the sum of the interior angles of a triangle is, and knowing the relationship between the exterior angles and two of the interior angles of a triangle. If you got that, good job. You're ready for section 2. First of all, doing section 1 homework, and then maybe going on to section 2. Till next time.